said it before I recorded it. Okay, so as far as notes, it's obvious you got the notes there that I'm going to do before 129, but I also need you to get out the notes from 115, which is partial fraction decomposition notes, because you actually do partial fraction over 3 days. What color did I make that? I hope it's
Yellow?
integration technique. It should either be pink or white. Yellow.
It is white.
We do have a set. We each have
Oh, it's gold because it's part of logistics. Never mind. All right, I'm good. Okay, so it's gold. Is that gold? It's white?
yellow.
It's white. Okay, so the one that's titled, that's white, that's titled set 115, 120, 126, partial fraction decomposition. It's white. It's titled set 115, 120, 126. You see?
I see it.
Okay, so set 115 was just
You can't be this organized.
basic partial fractions. Today is what you call repeated linear factors. And then later on you'll do irreducible quadratics, but I think you've seen all this already. Miss Becker, when are you taking the test?
I can take it next week on Tuesday.
All right, I'll take it. All right, so I'm at the bottom of the first page. Do you see set 120 objective? All right, this guy right here, that's what makes this new and different. When you get a squared linear term, you have to be careful. So I imagine, bless you, I reckon that the first person that tried to integrate this probably did something like, well, I know that usually when I do this, I just make an a for x plus 2 and a b for x plus 3 squared. I mean, isn't that what I'm doing? There's not a square, so it'd be logical to go there, yeah? Are you with me?
No.
Okay, you're not with me.
Yeah, no, I.
Okay, all right. Now, if you tried that, then you'd get 3 equals a times what?
X plus 3 squared.
X plus 3 squared and b times x plus 2. You'd probably let x equal -3, and you get 3 is b times -1, or b is -3, yeah? And if you let x equal -2, you get 3 equals a times 1 squared. So a is 3. So we would conclude that 3 over x plus 2, x plus 3 squared is equivalent to what? A is 3, and it goes over
X plus 2.
x plus 2, and b is -3, and it goes over
X plus 3 squared.
x plus 3 squared. And you would be tempted to just say, okay, and then I integrate cha-cha-cha. However, this you'll find is actually not true. If we were to check this and get a common denominator, then wouldn't the 3 over x plus 2 need to get multiplied by x plus 3 over x plus 3 squared? So times x squared plus 6x plus 9. And the -3 would need to get multiplied by x plus 2. Now if I do that, I get 3x squared plus 18x plus 27 minus 3x minus 6. That, I think you'll agree, in no way equals plain old 3. This does not equal 3. In other words, I found some adding of fractions that in no way is equal to what I started with. And therefore it's garbage. You down? All right, now then, So they said, what the freaking heck? Something's going wrong here. I thought I did it right, but that failed. So it must be a little more to it. And then the next person probably tried x plus 2 and just a normal x plus 3. And I can tell you that also fails, though I didn't give you the room for that. And through a little bit of trial and error, they realized that when you have a factor like this, when you have a repeated factor, you've got to, what I say is, build up to the square in power. Now, that means then that if you had, for example, a factor and a squared factor, then factor 1 is like normal. You have a denominator for factor 1, but the squared guy, you actually have to create two fractions for. One for the first power, and then one for the second. Now that's when it's a square. If it's a cube, then you would create one factor for the first, and then building up to a cube, you'd have to have a factor to the first, to the second, and to the third. You down? All right then. Let's try this then and do this properly. If I say that I have to do this build up to it way, then that same problem here, 3 over x plus 2, x plus 3 squared, would have to be decomposed into three fractions. A over x plus 2, b over x plus 3, and c over x plus 3 squared. Now when I clear the fractions, I get 3 equals a times x plus 3 squared, b times.
Wait, why would it only be squared? Shouldn't it be cubed? It's only
No,
squared.
so what's the common denominator you'd multiply by? Don't think you multiply by everything you see. You multiply by the least common multiple of the common denominator. So you'd multiply by x plus 2, and would you need x plus 3 cubed to get rid of the denominators, or would just x plus 3 squared be? So you're just going to multiply by x plus 3 squared. So you have a times x plus 3 squared, b times x plus 2 and another x plus 3, and c times
X plus 2.
x plus 2. All right. We're getting there. Now then, if we let x equal, and what should we let x equal?
But
Three.
that's equal.
Negative 3 sounds good. So 3 equals, the a, does it drop out or stay? A drops out. B, does it drop out or stay? Drop out. And C gets multiplied by negative 1, therefore C is negative 3. Cool. All right. Now, what should we let otherwise? Let x equal
2.
negative 2. If I do that, 3 equals, does A drop out or stay?
Same.
Stay. And I get A times
1.
1. So A, and then the others drop out, yay?
Yeah.
So A is 3. All right, now here's where I might do things slightly different than this can ever through. There are two methods for solving the rest. Do you agree we still have to find B? Okay, so how would you go about finding B? Plug them in and do what? And solve? So you plug in your A and your B,
Your A and your C.
your A and your C, and then how would you solve?
So
You
have
could let
one
x
term that you
equal
want
something that doesn't make 0. 1.
Oh, okay, so I have a quicker way. Let's do it this way, all right? So, would you consider then that if I distributed all this out, I would have A times some x squareds and x's and constants, B times some x squareds and x's and constants, you with me? And C times some x's. Now, if I did that then rearranged, in terms of the x squareds, what's the coefficient of all the x squareds, please? What all goes into x squareds? A and B. There are a plus b x squared. So you down? This, you'll be able to do this mentally in a minute. Now, that's all I really need. I don't give a rip about the rest. How many x squareds are there on this side?
None.
There are none. So that implies that a plus b must be nothing. You follow? A plus, because there are no x squareds on the left, there has to be no x squareds after it's all said and done to the right. Well, if a plus b is 0 and a is 3, then b must be negative 3. Therefore, my integral becomes, back to my setup, a over x plus 2. Now what is a again?
3.
3. Then I came to b over x plus 3. What's b? Negative 3 over x plus 3. And then I had c over x plus 3 squared. What's c? Negative 3 over x plus 3 squared. Now there is another small difference here besides the repeated linear factors, and that's the integration of that last factor is different. The first two are still natural log. 3 natural log of x plus 2 minus 3 natural log of x plus 3. Be aware that they might combine those by log rules in the answers. I don't really care if you do or don't. But what is the antiderivative of that last one? Is it natural log if the exponent is 2, not 1? No. So what is the power? And I doubt I would actually take the time to write this, but wouldn't you agree that if I wrote that with an exponent so I could use the power rule, it's 2 to the negative second. And by power rule, I'd raise the power and divide by the new power. So what's the antiderivative of that? So positive 3 over x plus 3 to the, raise it by 1. Negative 2 plus 1. Right? Are you down? Are you with me?
Yes.
Okay. And plus c. All right. Will you fix your, that I spelled coefficient wrong. That's really embarrassing for my future study. Okay. Will you give this a go on your own, and we'll see how we compare. How many fractions are you going to get? 4. You'll get 4, because to build up to a cube you need 3 factors, and there's one other factor. Great. What are you doing? What order are you doing? Are you doing the x's first or the x's last?
X's first.
X's first. Okay. Just so we, not that it matters, but if our work is going to. Straightforward coefficients of negative 2/3 and 2/27. Okay, that's sounds like on the right track. little harder. You working your way through A and B? Just already or not quite? Okay, so again, depending on the order in which you found things, A, B, C, and D might be different depending on what you put over what. But based on going x squared, x cubed, x minus 3, and A, B, C, D, I get C is negative 2/3. D is 2/27. That was pretty straightforward, yeah? Okay, how did this other idea of finding A and B go? Did you?
A equals
Negative 2/27 by virtue of the fact that the cubes have to zero out, right?
Yes.
Okay, so A is negative 2/27. For the B, you could either look at squares or x's. I started with x squareds, and there are no x squareds in the left, and there are negative 3a and b x squareds on the right, yay? And no other x squareds. So b is 3a, which means b is negative 6/20. Oh, I could cancel, huh? Negative 2/9. Okay, cool.
How did you get the negative 3a?
Good call. So when I looked at, so first of all, my first place I looked at was here. I said, all right, involving b is x squareds. So then I looked at all these other guys and said, all right, where else are there x squareds? This has an ax cubed, and that's great, and a negative 3ax squared. So there's some x squareds there. Negative 3ax squareds, bx squareds. This has no x squareds, and this has no x squareds. So the total of all the terms with x squares is negative 3a and b. That's for that. Does that make sense? Okay. Now, if negative 3a plus b needs to zero out because there are no x squareds on the left, then that implies b has to be 3 times whatever a is. And using your previous a, negative 2/9 is what I get for b. We cool? All right. So rewriting my integral then, a over x becomes negative 2/27 over x. B over x squared is negative 2/9 over x squared. C over x cubed is negative 2/3 over x cubed. And D is 2/27. Cool. Last but not least, integrating. What's the antiderivative of negative 2/27 over x?
Negative 2/27 is natural log of absolute value of x plus.
Log of the absolute value of x. Okay, what's the antiderivative of negative? I'm just going to write the negative 2/9. What's the antiderivative of x to the negative 2?
2 over 9.
Negative 1 over x.
Yeah, negative 1 over x, or x to the negative 1 over negative 1, or yeah, I like negative 1 over x. Let's just do that, shall we? So that might have changed to positive 2 over 9x, yeah? Okay. What is the antiderivative of x to the negative 3?
Negative 1 over 2x squared.
Negative 1 over 2x squared. I agree with that. Feel free, if you want to just keep it ugly, x to the negative 3's derivative is x to the negative 2 over negative 2, but whatever you want. And the last one, what's the antiderivative of x to the 2/27 over x minus 3?
227 is that's the value of
Okay, cool. It took longer than I thought. I thought this was a layup, but that's not as easy as I remember. All right, so is that going okay? All right, switch gears and get to the green, please. I used to teach 129 when 129 came, but it just wasn't enough time to really get good at it. 129 is a really hard set if you don't teach a little ahead of time. So I'm taking a good chunk of 119, 129 and teaching it right now. All right, so the idea of the day is how do you find the area inside polar bears? Height? Height. Here goes. Say I wanted to find the area enclosed by r equals 4 cosine theta. Now, when you go to discover math on your own, you're going to play around with it, but it's always nice to have some kind of problem you know the answer to, so you know if your method is right? I'm using r equals 4 cosine theta because I know the area should be the area of a circle. I know my answer should be pi r squared is the radius 2 or 4, 2, and therefore I know my answer should be 4 pi, or 12.56-ish, right? All right, cool. Now, check it out, my friends. You have to understand or remember that polar and rectangular are not the same. So when you go to do area, you're not going to get rectangles because you're not moving side to side because you're not moving x, you're moving theta. When we found area in rectangular, we use rectangles because by changing x, you get a little sideways movement, or by changing y, you get a little vertical movement. And so in those cases, the differential showed up as, what did I mean by that? A base or height of a rectangle. And the other part was the other part of the rectangle. The function usually then came into play for finding the base of the height of the rectangle. You with me?
Yeah.
Now in polar, switch gears. In polar, equations are in terms of theta, and theta is not a measure of right, left, or up, down movement. Polar, or theta, is a measure of degrees, or angle turning, yeah? So imagine if you had a theta, and you change theta by a little. Wouldn't you then go, whoop? So something like that. That's a small change in theta. I changed the angle a little bit. Down? All right, so the differential means a small angle change. Now this is one more reason to love math, because this is cool. You could actually look at that geometric, now I'm trying to accumulate the area of all these. Every time I make a little slice, I'm getting lots of these kind of shapes. And the total area would be the sum of those little shapes. Now my question to you is, what shape, or what two shapes, geometrically speaking, do those little shapes look like? Pies. Okay. So sectors is what I was looking for. Okay. So you could say it looks like a sector, which is a portion of a circle. That's true. Or what else? Now, keep in mind, I understand that I'm writing fairly big wedges, and so it feels like that side is curvy, yeah? But remember, d theta is so small that it's only like this big. Now, what would this side look curvy if it was microscopic? Or to the naked eye, would it look
So rectangle.
linear, not rectangle?
Triangle.
Triangle, okay. It would look like a triangle because it would look locally linear. The curve would be such a small part of the curve, it would look to the eye like a line. Now, this is cool. When you draw many slices in polar, you get lots of wedge shapes like this. Many of them. Now, let's talk finding the area then. I think you'll agree that it's either going to be the sum of many sectors or the infinite sum of many triangles. You down? And they will actually yield the same formula both ways. Cool. All right, so do you remember how to find the area of a sector?
No.
All right. Just conceptually, if you were to think your way through this with your little brother saying, hey, can you help me find the area of this piece? You'd say it is?
A fraction of a circle.
That's, you just start to know, a fraction of a circle. It's a fraction of the total area, right? All right, so start there. It's a fraction of the area of a circle. What fraction? D theta over 2 pi. Oui? Right on. And what about the area of a circle? Pi r squared. So it seems like the area then is 1/2 r squared d theta. Now on the surface that might seem like, oh, that seems like bad calculus because it's got two variables, right? But remember, what is r? R is an equation of theta. So you would put the equation for r in there and you've got a theta integral, right? So we should really say r is a function of theta squared. And so you're always integrating with respect to theta. And the limits of integration, they'll be from theta to theta. I'll talk about that in a second. All right, you with me so far? All right, so I have a triangle. What are two of the three ways you've learned? Actually, I don't know if you've learned three. What are some ways to find area of a triangle? Base times height divided by 2. Write that down and stretch that out because that sucks. Okay, what else?
AB cosine.
1/2 AB sine C. Is that what you meant to say?
I guess.
Yeah, because it's not AB sine C. It's 1/2 AB sine C. Yeah? All right, cool. What are rather A and B? What do they represent in the formula?
The size.
Sides. They are two sides to the triangle, yeah? Well, aren't A and B then just different radii? And in fact, if those are close enough, they're not even really different bars. They approach the same. And so those A and B are really just different R's. And sine of C, sine of d theta. Now that's a bit of a problem. Those of you who are in AP Physics, you will find this, I think, usually you guys are talking about this at the same time, yeah? Sine of d theta, what the freak?
It's d theta,
It's d theta, why?
because it's about the same thing.
Yeah, for tiny theta, sine of d theta, actually, for tiny, let's just call it x, okay? For any tiny x, the sine of x is pretty much equal to x. Now that's not a leap, because you actually done that problem a gazillion billion times. If I said, hey, how do sine of x and x compare as you look at really small, what is that limit every time? 1. Doesn't that imply that they're roughly the same for tiny values? So it is no leap for tiny x, these are the same. It is no leap to then say that this is equivalent to 1/2 r squared, and sine of d theta is just d theta. All right. Now, the hardest part by far of this is the bounds. Bounds in rectangular, they're nothing. Anybody can see the left and the right edge, or the low and the top edge. Polar is rough. Let me explain why. And this is the most difficult part to wade through without making a mistake. Students want to always just go from 0 to 2 pi, because that's the whole space. Not so much. Okay, so check this out. If you said r equals 4 cosine of theta, let's track through some angles here. When at theta equals 0, r is 4. Right? So I'm getting points, getting points, getting points, getting points. When theta equals pi over 2, r is 0. So at that point, that's when I'm in there. Then I'm starting to get negatives. In this quadrant, cosine's negative, yeah?
Yes.
And if cosine's negative, then r is negative. And if r is negative, then I'm not going forward towards these angles, I'm going
Backward.
backwards. So I'd be getting angles, angles until theta is 0 and r is negative 4. That's when I finish going backwards and I'm there. Down.
Yeah.
Now, if I kept doing angles here, you've completed the circle. The circle is complete in pi. If I kept going, then I would start to get backwards points, backwards points, backwards points, backwards points until 0, and then forwards points, forward points. If I kept going from pi to 2 pi, I get the circle again. Are you with? Okay. In pi to 2 pi, get the same circle. So if you did, area is 1/2, and you say, oh, screw it, I'll just go 0 to 2 pi, because that's the whole figure, squared, and you put in this would not give you one circle, it would give you 2. Put it into your calculator, please. Okay, so I am getting 25.1327. That is 8 pi. And what do we know the area to be?
4 pi.
4 pi. We know it was a circle, pi r squared. It should have been 4 pi. So you can see that you're getting double area. My point then is you never go 0 to 2 pi, because different figures, some figures get made in pi. Some figures get made in 2 pi. Some figures get made in less than that. Every figure takes different amounts of theta to complete the figure, and you might be getting the figure many times over. So the key to doing this well is to find the minimum amount of area and then use symmetry. Here's an example or 2 examples, and you'll try 2 examples. All right, so this is how you would do polar area well. If you know the figure, then you should use the figure. What does 4 cosine 2 theta's graph look like?
A plus sign,
Circles on each side.
circles.
Yes. So we got our rows 1, 2, 3, 4 with this kind of. It goes whoopity-doo. Okay. That's what it looks like. Although my screen is kind of stretched, so it doesn't look right. All right. Cool. You ready?
Yeah.
Now I want you to start at 0 and tell me how long does it take to get a minimum amount of this rows and then just multiply to get the rest. Couldn't I just say draw a spoke, draw a spoke, draw a spoke until that's done? And then multiply by 8. So I'm going to find the area as 8 times the shaded region. Follow?
Yeah.
All right, now you need to find when R is at a max, that's the start of it, and when R is 0, that's the end of the region. When you're not going out of the origin, you're back to the origin. Well, what's the first angle when you're at that point, when you're going as far as you can? It's 0. When is R 0? Well, here's R, 4 cosine of 2 theta. We want to know when it's 0.
Theta is pi over 4.
Right. We know that cosine 0 is out at pi over 2, so that means that theta would have to start at pi over 4. When I reach pi over 4, the rose is into the origin. So I could just say, what's the area from 0 to pi over 4, and then multiply it by 8. Now I know the formula is 1/2 the radius squared d theta. And instead of the radius being r, I write the equation of r, which is 4 plus 19 theta. How did you calculate it? Feel free to just call it 4 instead of 8 times a half, if you like. If you want to write 8 times a half, that's fine too. Make sure you're careful with your parentheses. I guess you could use theta or x, it doesn't really matter what you call it. What'd you get?
25.
25.132-ish, yes?
Yeah.
Okay. Now, I'm going to let you do these by calculator, though you absolutely have the skill to do this. You know how to do cosine squared sans antiderivative, right? Power reduction and all that, but we'll focus on conceptual. All right, let's try one more, the next one, and then you'll try two together, or on your own rather. 5 plus 3 sine theta, what kind of family of graph is it? All I heard is a bunch of Li, Ma, San, Lima San, Lima San. Okay, there are 4 types of Lima San. Do you remember what they are? Convex, that is an egg shape. Concave, which has a dimple. Hard, cardioid. And loop. Okay, so let's see. This one has a little bigger first number, so it's not a loop or a cardioid, but it's only a little burger. I'm really hungry. So it's a little bigger, so it is a concave or dimple. It's got a dimple to it, right? Okay, so when x, change the scale because we're going to need to go out 8. Yes, let's do. So I only want you to find at the pi over 2. So at 0, what is r? 5, because the sign is 0 there, all right? At pi over 2, what is r? 8. At pi, what is r? 5. And at 3 pi over 2, what is 2? 2. Okay. So if you draw a little dimple-y kind of guy, then there, yeah? All right, so in terms of using symmetry, could I go 0 to pi over 2? No. Okay? So the symmetry, I think you'll agree, is right down the middle. What else could I do? negative pi over 2 to pi over 2. Now that would be starting here and going this way until I got there, yeah? And then double it. So that sounds like a good idea. Double a half r squared. Get the symmetry factor in the formula. Then fill in the details. The limits, we said we're going to go from negative pi over 2 to 3 pi over 2, and pi over 2, sorry, pi over 2, and 5 plus 3 sine theta, yeah?
Yeah.
Okay, so throw that in your calculator for me real quick, and then we're going to talk about something else. What are we doing on time? Harder, not time break. Anybody? 92.677. 6? 7? Okay. So, question. What if I said, what if your colleague, you wouldn't do this because you're so smart, but what if your colleague said, oh, I did 3 pi over 2 to pi over 2. 3 pi over 2 to pi over 2. What kind of answer would they get?
Negative, Bruce.
Why?
Because it's backwards.
Yeah, you're actually, isn't theta decreasing if you go from 3 pi over 2 to pi over 2? That's a negative d theta. You're actually going to get a negative area because d theta is negative. So you should always go, as always, you should go from lesser to greater, however that might look. Could I have gone from pi over 2 to 3 pi over 2?
Yeah.
Double it. Yeah, that would work, okay? All right, try those guys on your own, and we will confirm it. I keep giving you different graphs. That must be really aggravating. You can see here I'm not giving you the pi over 12 like I sometimes do. Those are just the reference singles in there, pi over 6, pi over 4, pi over 3. How are we doing on the first one? Okay, do you agree that the absolute minimum it would take to get symmetry is a half a petal? Yes? Now, if you do that, then half of 3 petals is 6 times the area. The question then is, if you do it that way, what's the start, which is the origin, and then how long does it take to get to that tip of the rose? And so what are your limits if you did it that way?
It would have been 0 to 5 or 6.
0 to 5 or 6. Now, some people then say, I'm just going to do 1 petal, which is from 0 until it's back into the origin. If you do that, then it's 3 petals times the area formula. In that case, it's 0 to pi over 3. They both work out the same. The answer is 19-ish, I think. 19.635. Did you get that?
Yes.
Excellent. All right. If you haven't already done so, try the other one. Double is right at a cardioid, yeah? Or sorry, they're equal, not double. Sorry, what again, use symmetry. So what kind of angles did you use to get a half of a figure? 0 to pi. 0 to pi, indeed. Okay. And what'd you get for an area there?
8.850.
Do we all agree?
No.
No?
Oh, 18. I'm just not good at reading.
18.850?
Yeah,
Or no?
that's what I've done. And I can read.
Agree, disagree? Elaine, you down? That's good enough for me. If Elaine says yes, then 100%. All right. This is the problem now. You have 2 minutes for all your questions. So,
That's where.
I don't want to get too behind, so this is what I want you to do. Would you get out set 119 and just tell me what questions you would like me to work this weekend, so at least I could work the questions and put them on my website, and I won't have 2 sets to do on Tuesday. Say again? The oh, right. I'll put all the replacement answers on there, sorry. Good question, good point. So all replacements will be there. What else? 16? 11? So all replacements, 16, 11. Uh-oh. Okay. 3. 4. Okay. The tests are going pretty well. I probably will have them done depending on how bad Elizabeth is. I might have them done by the end of the day if you want to swing by after 7. Just have one question. Is that it? Okay. Well, that's it. I will put those up this weekend. I probably won't put them up today, so get a life if you want to check them today. But check them some other time this weekend. And have a great 3-day weekend. You are so far. You deserve a 3-day weekend. Thank you. We all deserve a good break. Am I right?
Do you guys have to work on much?
We do not. I've been to the parade. I've never been to the parade. Martin Luther King parade. I don't know what.
It's not like the biggest piece.
Are they having a parade? Martin Luther King?
You want to take some
I mean, there's a lot. I've never really understood what they're saying. Just because, like, there's a lot of influential figures in history. If it's just about celebrating that, we should just have an influential figures in history day. Or a civil rights day.
Civil Rights Day would make a lot of sense.
Like, there were a lot of other people who were involved in that movement. Other than Martin
You know
Luther
what?
King.
We should have a vacation on the day that Abraham Lincoln died.
We said, like, there's no need to day. And we the ones who pushed the
That's my
amendment.
birthday every year. We should have a vacation day on the day Abraham Lincoln died.
We really should.
See, it's my birthday every year. I have my birthday every year.
Abraham Lincoln Lincoln Day. That would make sense. He was fantastic. He did a lot.
But we only have President Day for him.
But you would then. So it's not
In the
AG,
real
that's
scheme of
big
things,
number.
Martin Luther King Jr. was influential, yes, but like also all he did was give speeches.
Have a great weekend.
So like,
Who, Martin Luther King?
yeah, all he did was read things and give speeches.
I'm being
That's
slightly
something.
selfish
He
because
did go to jail.
So did like every other civil rights activist, though.
it's
But
There were like literally thousands of them who went to jail. There should be an Abraham Lincoln Day
Were
because
they-
he's actually the person who made the difference.
well, there's President's Day.
well, yeah, but that's like
I
he.
mean, it's his birthday.
Abraham
Washington's
Lincoln
birthday.
kept us from falling apart as a nation.
True.
So
Don't
he
you
just-
agree though? But they're both the right man at the right time. I mean, Martin Luther King,
you're not gonna win on
I
the
mean,
same
yeah,
day.
why,
I want
why
my
isn't there a
birthday
Rosa Parks Day then?
off.
because she's great, but she's not an eloquent speaker. At least
Right,
not the
but she
interview I
did more than he. She did.
Harriet Tubman made speeches.
True.
saw.
She's got a Harriet Tubman Day.
Exactly.
Make a good point. Oops, I forgot to stop this. Oh, we got a nice debate on tape.